In this video, we want to look at finding the actual derivative of a function. And the example we're going to look at here is f of x equals 3x squared. And we're going to use the limit definition that we talked about in an earlier video. If you recall, we said that the derivative f prime of x is equal to the limit of x plus delta x minus f of x divided by delta x, and we're looking at the limit as delta x goes to 0. So using this limit definition of our derivative, we want to find the derivative of 3x squared. So to do that, we first need to calculate f of x plus delta x. So remember, we're trying to find f of x plus delta x. Now, maybe as a quick review over here before we begin, I want to make sure you recall, if we want to evaluate this function, kind of as a side note here, if I said we want to find f of 2, that means we're going to take 2 and plug that in for the function, and we would get 3 times 2 squared, which would be equal to 3 times 4, which is 12. Or if I said we want to evaluate the function f of, let's say, instead of 2, what if I said f of b? Well, you would simply plug b in for x, and you would end up with 3b squared. So over here, we're doing the exact same thing to evaluate this function, except for now, we're not plugging into our b, we're plugging in x plus delta x. So if we go up to the function, we're going to plug this in for x. So we get 3 times x plus delta x, the whole quantity is squared. And then it's minus f of x. Well, f of x is simply the 3x squared. And all of this is divided by delta x. Okay, so once again, f of x plus delta x, we're plugging x plus delta x in for x, so we get 3x plus delta x squared minus the function. Well, the function is simply 3x squared over delta x. So now, how do we evaluate this? Well, we simply cannot use direct substitution, because if we try to find the limit by direct substitution, we get 0 in the denominator. So the goal here to evaluate this limit is to somehow to cancel the delta x off the bottom. So we're simply going to simplify this expression, and the first step is we need to square x plus delta x. So remember, to square this, you actually have to FOIL this out. So you're going to get x squared plus 2x delta x plus delta x squared minus 3x squared all over delta x. Now you're going to find out this is a little bit time consuming, a little bit tedious, but I found out if you skip too many steps, you're more likely to make a mistake. So really all you're doing is basically algebra, multiplying and collecting your like terms. So if we distribute the 3, you get 3x squared plus 6x delta x plus 3 delta x squared minus 3x squared all over delta x. And if we combine our like terms, what happens? Well, you notice we have 3x squared is going to cancel out minus 3x squared. So you're left with 6x delta x plus 3 delta x squared all over delta x. So now, in the numerator, you'll notice each term left in the numerator now contains a delta x. So that means we can factor out a delta x and then by doing so we can cancel the delta x off the bottom. And now if we're trying to calculate the limit as delta x goes to 0, all we have is 6x plus 3 delta x. So now we eliminated the delta x on the bottom, so therefore we can use our direct substitution. So now the limit would be 6x plus 3 times delta x, which is 0. So that means we end up with 6x. And this here is our derivative. Now, this derivative here, remember, this derivative will allow us to find the slope or the instantaneous rate of change at any point on the graph. So this here is going to give us the slope of the tangent line at any point xy. So if we were to look at the graph of this particular function, so let's go back to original function, and if you recall, the original function here is 3x squared. So if we look at a rough graph of the original function, so if we were to quickly plot some points when x is 1, your y would be 3, or negative 1, y is 3. When x is 2, y is 12. When x is negative 2, y is 12. So here we end up with the graph of our parabola. And the next question might be is, how can we find the slope of the tangent line at the point 1, 3? Well, if we locate the point 1, 3, so here we have over 1 up 3, so here's our point, and we want to find the slope of the line at the point 1, 3. Well, we're going to simply use our derivative that we found. So we're going to take f prime of x equals 6x, and all we have to do is evaluate the derivative at the point 1, 3, and all we really need to know is the x value. So if we evaluate the derivative at 1, we end up with 6. So that tells us this here is the slope or the instantaneous rate of change of our tangent line at this point. So if we were to draw our tangent line, the slope of this line here, the rate of change, and our tangent line touches this point at 1, 3. So the rate of change here would be 6, which means you would be going over 1 and up 6. Now, for example, what if you wanted to find, what do you think is going to happen if we wanted to find the slope of the tangent line at -1? Well, if we wanted to find the slope at -1, 3, then you would simply take the derivative and evaluate that at -1, and you would end up with 6 times -1. So you end up with a slope of -6, which should be obvious. Your tangent line here is negative because the line is going down. So here you can find the slope or the instantaneous rate of change at any point on this graph by simply using the derivative. Now, let's say, for example, over here we wanted to find the derivative of the tangent line at the point 1, 3. How can we now find the equation we want to find the equation of the tangent line. Well, if we want to find the equation of any line, there's basically two things we need to know. We need to know the slope of the line, and we need to know a point on the line. Well, we know the point on the line is 1, 3. And we know from above, we just calculated the slope of our line to be 6. So now we have a point and we have the slope. So we can easily calculate or find the equation. And one way we can do that is we could simply use y equals mx plus b. So we know that we could plug in 3 equals 6 times 1 plus b. So therefore b is equal to -3. So that tells us y equals our slope 6x plus b, so that's plus a -3 or simply -3. So y equals 6x minus 3 is going to be the slope, the equation of our tangent line. So you can see here there's many different things that we could be asked to find using the derivative. So the key thing we want to go back here is if we're trying to find the derivative, we're really finding the instantaneous rate of change or the slope formula, which in this case we find f prime equals 6x. So this here is really the derivative of our function, which is really kind of like a slope formula so that we can evaluate the slope at any point on this graph. So if you wanted to know the slope at when x is over here, let's say all the way over at 10, well, all you'd have to do is plug 10 in and you'd get f prime of x equals 6 times 10. So your slope would be 60. So now that you have the formula, that will allow you to find the instantaneous rate of change at any point.